This is pre-AP pre-calculus, note section 9.3, developing and using the unit circle. What the directions are telling us to do is on all these inside blanks, label this circle counting by 30 degrees and counting by 45 degrees. We are going to call the positive x-axis 0 degrees. A complete revolution is 360 degrees. If we count by 30s, we're going to have 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150, 180, 210, sorry, I threw a 45 in there, and then 240 degrees, 270, I'm just adding 30 each time, 300, 330, and then back to the beginning, which is 360. Supposed to also count by 45 degrees. So we got 0 at the beginning, and then 45, and then 90, we already got, and then add 45, we get 135, add 45, we get 180, add 45, we get 225 degrees, add 45, we get 270 degrees, add 45, we get 315 degrees, add 45, then we're back to 360. Easy enough. The directions say on the outside, we're supposed to measure these angles in radians. Now, a fact about radians is that 0 radians is on the positive x-axis. If you make a complete revolution, it's 2 pi radians. Supposed to count by pi over 6. Pi over 6 is the same as 30 degrees. So if we count by pi over 6, we're going to have 1 pi over 6, and then 2 pi over 6, and then 3 pi over 6, and then 4 pi over 6, and then 5 pi over 6, and then 6 pi over 6, and 7 pi over 6, and 8 pi over 6, and 9 pi over 6, and 10 pi over 6, and 11 pi over 6, and back to the beginning, which is 12 pi over 6. If I didn't write it on the blank, oh well, I should have written some of these on the blank. I intentionally didn't write some of those on the blank because they're going to reduce. 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 is 2/3 pi. 5 pi over 6 is already reduced. Let me write that more legible. 6 pi over 6 is pi. 7 pi over 6 is already reduced. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6 is already reduced. And 12 pi over 6 we already had written as 2 pi. If we count by pi over 4s, start at the beginning, positive x-axis is 0 pi over 4. At 45 degrees, it's 1 pi over 4. And then at the positive y-axis, we got 2 pi over 4, which reduces. Then at 135 degrees is 3 pi over 4. Negative x-axis is 4 pi over 4, which reduces to pi, we already have. 225 would be 5 pi over 4. The negative y-axis is 6 pi over 4. And then 315 is 7 pi over 4. And then back to the beginning would be 8 pi over 4, which reduces to 2 pi. You need to be able to label this unit circle, counting by 30 degrees and 45 degrees, and also label it counting by pi over 3s and pi over 4s. Just remind you, what is a unit circle? A unit circle has the center at the origin and has a radius of 1. Moving on. Now it says here on this backside, we just want to label the angles inside the circle in radians. So I'll just do that real quick. We got 0 and 2 pi, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3. Yes, we just did this on the other side. 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6. Now, in these other blanks, we're going to write down the ordered pairs of each of these numbers. Now, let's just do some easy ones. Now, this is assuming it's a unit circle, so that means the radius is 1. This ordered pair would have to be 1, 0. Now, why is that? If the radius is 1, we're going 1 unit to the right to get to this point right here. And we went up or down 0, so the y value is 0. This ordered pair here would be 0, 1. We went left to right, none. We went up 1. This ordered pair over here would be negative 1, 0. The negative y-axis, that would be the ordered pair 0, negative 1. And then back to the beginning, it's 1, 0. Those 4 ordered pairs are from quadrantal angles. Let's review some things that we know about special right triangles. This is just a portion of the unit circle that I'm drawing right here. So I'm going to draw 2 of these. Yours doesn't have to be as beautiful as mine. And let's say that I went pi over 6 degrees, and I wanted to know, it's not a very good, pi over 6 is more like here if it was to scale. I want to know what this ordered pair is right here. What's the ordered pair of when this radius of 1 hits the unit circle? What is the x value and y value? How far left, how far right? Essentially, we want to know what is the distance, this blue distance, and what is the red distance. The red distance is going to be the y value, and the blue distance is the x value. Notice I just made a right triangle. Not just any right triangle. This is a 30, 60, 90. First of all, if I'm deciding to make it a right triangle, that has to be 90. Pi over 6 means pi divided by 6. Pi is 180 degrees. 180 degrees divided by 6 is 30. That makes this a 30, 60, 90. Special right triangle that you must know. That makes this other angle 60 degrees, which is pi over 3. In a 30, 60, 90 triangle, whoops, I didn't want to move that. How I had you do this in geometry is we called the short leg opposite of pi over 6. We called the long leg, which is opposite 60, the short leg times the square root of 3. And we called the hypotenuse 2 times the short leg. If we take that equation, 1 is equal to 2 times the short leg, and we divide by 2, we get the short leg is a half. Big picture wise, if you don't make those equations, whatever the short leg is, the hypotenuse has to be twice the size. So going backward to the hypotenuse is 1, the short leg has to be half of that. Half of 1 is 1/2. Once we know the short leg is a half, opposite pi over 3 has to be that times the square root of 3, which we would usually write as square root of 3 over 2. So what is the ordered pair? Well, we have to go to the right, pi over 3, and we have to go up 1/2. So that tells us at pi over 6, the terminal side of the angle will hit the circle at the ordered pair pi over I'm sorry, square root of 3 over 2, 1/2. Let's put that up here in our unit circle. This is square root of 3 over 2, 1/2. Now let's examine. I actually might draw another one of these little fellas. Make this a little smaller. I know you can't do that, and I apologize. Let's go with this angle here, which is pi over 3. That makes this pi over 6. The radius is 1. The short leg is half of that. The long leg is the short leg times the square root of 3, so that's square root of 3 over 2. That makes this ordered pair 1/2 square root of 3 over 2. If you put that into your unit circle, up here, then that makes that ordered pair like so. And more specifically, if I were to draw this in here, we got this triangle. That didn't work out well. And then if we draw this other one here, it's the same triangle. It's just the x and y, the legs, the x becomes the y and the y becomes the x. So essentially, this x value becomes the y value and this y value becomes the x value. What about pi over 4? Let's check that out. Pi over 4, which is 45 degrees, it's going to make this a 45, 45, 90. And a 45, 45, 90, well, yeah, I'll do that. Let's say the short legs are both the same, and the hypotenuse is the short leg times the square root of 2. This is a unit circle. In a unit circle, the radius has to be 1. If I take that little equation and I solve for the short leg, I'm going to get the short leg is 1 divided by the square root of 2. If you rationalize your denominator by multiplying by 1 in the form of square root of 2 over 2, you're going to get square root of 2 over 2 as the length of the short leg. Short legs are the same in a 45, 45, 90. So that means the vertex, not the vertex, the ordered pair, well, where this tangent, not this tangent, I'm sorry, I'm misspeaking. The terminal side, what I just drew in red, touches the circle at this point right here. It's going to have an ordered pair of to the right, square root of 2 over 2, and up, square root of 2 over 2. I can put that into my unit circle. That is quadrant 1. Quadrant 1 is complete. Once quadrant 1 is complete, this is real easy to fill everything else out. So I'd like to point some things out. Pi over 6 has a reference angle of pi over 6. 5 pi over 6 has a reference angle of pi over 6. Same reference angle. So it's the same reference triangle. So that means that these answers are the same with one exception. I'll do those in red. Because it's the same triangle. What's the difference in quadrant 2? Well, the difference is in quadrant 2, we had to go left. So the x value is negative and the y value is positive. Likewise, pi over 4 and 3 pi over 4, they have the same reference angle. Therefore, they have the same reference triangle, which means these ordered pairs that we have over here are the same. What's the difference? The difference is we went left. The x value is negative in quadrant 2. Likewise, if we take pi over 3 and 2 pi over 3, they have the same reference angle. So this ordered pair for pi over 3 has the same absolute value as the ordered pair for 2 pi over 3. The difference is we went left, so the x value is negative. So compare these ordered pairs. With the exception of the signs, they're the same. Another way to look at it is if you take the ordered pairs we have on the right and make a horizontal reflection, when you make a horizontal reflection, the x values change signs. The y values don't change at all. If we then take this ordered pair and reflect it down, and you do a vertical reflection, the y value changes sign. Do that for each of these. It's the same ordered pairs, it's just the signs are changing. Because in quadrant 4, we all know we go to the right and we go down. When we go down, it's negative. So quadrant 3, you can reflect what's in quadrant 4 or reflect down what's in quadrant 2. I'm going to reflect what's down in quadrant 2. The y values are going to change signs. So I'm going to write these in, and then I'll change the signs here in a moment. The same ordered pairs because it's the same reference angles. Negative, negative, negative. Big picture wise, if you check this out, in quadrant 1, x and y values are both positive. In quadrant 2, x values are negative, y values are positive. In quadrant 3, x and y values are both negative. In quadrant 4, x's are positive and y's are negative. Also, big picture wise, the reason that these ordered pairs are all the same but different signs is because they all have the same reference angle of pi over 6. So it's the same reference triangle. Pi over 4, 5 pi over 4, 3 pi over 4, and 7 pi over 4, they all have the same reference angles. That's why those ordered pairs are the same with the exception of the signs. And pi over 3, 4 pi over 3, 2 pi over 3, and 5 pi over 3, they have the same reference angles and the same reference triangles. So those ordered pairs are all the same, but with different signs. You're going to have a quiz tomorrow. And it is going to be what you see right here. And the answer to it is what you see right here. This is writing all the angles in radians and writing the ordered pairs of the unit circle. That's going to conclude the first part of these notes. I'm going to add a second part to this, but I'm going to put a stop to this right now.